We want to solve some equations that contain radicals. Square root x plus 1 is equal to 2. I want to solve this for x. I need to get rid of the square root that's on the left side. I can do that by squaring both sides of the equation, and I can do that anytime I want as long as I check my solutions back in the original equation. The square of this square root just gives me what's inside, x plus 1. The square of 2 is 4. Add negative 1 to both sides. X comes out to be 3. Now let's just check that real quick. Square root of 3 plus 1, is that equal to 2? Well, 3 plus 1 is 4. The positive square root of 4 is 2. I get 2 is equal to 2. So that solution, that solution checks when I substitute it back into the original equation. Whenever I square both sides of an equation or raise both sides of an equation to any even power, I always have to check my solution back in the original equation. That is the equation that existed before I squared both sides. Next problem. Positive square root of x minus 9 is equal to negative 6. I can tell by looking at this that there's no solution, because this side is a positive number and this side is a negative number, and there is no positive number that's equal to a negative number. So I'm going to say over here, no solution. But let's just try to solve it anyways and see what happens. Square both sides. The square of the square root of x minus 9 is x minus 9. The square of negative 6 is 36. Add 9 to both sides. X is equal to 45. So check and see if that solution works. Square root of 45 minus 9 is equal to negative 6. Question mark. 45 minus 9 is 36. The positive square root of 36 is 6, equal negative 6. So no, that does not work. 6 is not equal to negative 6. But the fact is this. When x is 45, this expression is 6. This expression is negative 6. When I square both of them, I get 36. So what happens is sometimes when you square both sides of an equation, you'll take a false statement and turn it into a true statement. It looks like you have a solution, but you don't. How do you solve this problem? Always check your solutions in the original equation. Problem 3, I have a square root minus 3 is equal to 2. I want to start by adding 3 to both sides. Square root 3x plus 4 is equal to 5. Now I'll square both sides and get 3x plus 4 is equal to 25. Add negative 4 to both sides. 3x is equal to 21. Divide both sides by 3. X is equal to 7. Take that x equals 7, put it back in the original equation. 3 times 7 is 21 plus 4 is 25. The positive square root of which is 5 minus 3 is 2. So 2 equal 2, I get a true statement. One last problem. Square root of x plus 3 is equal to x minus 3. I'll square each side of this. When I square this square root, I just get x plus 3. When I square x minus 3, I get x squared minus 6x plus 9. Quadratic equation. Let's put it in standard form. I'll add negative x to both sides and negative 3. 0 is equal to x squared minus 7x. Let's see, when I subtract 3, get plus 6. 0 is equal to x minus 6, x minus 1. Set this equal to 0, x is equal to 6. Set this equal to 0, x is equal to 1. I'll check x equals 6 back in my original equation. 6 plus 3 is 9, the positive square root of which is 3. 6 minus 3 is 3, so that solution checks. So that's okay. X equal 1, I put 1 back in here. 1 plus 3 is 4, the positive square root of which is 2. Put 1 back in here. 1 minus 3 is negative 2. I get 2 equal to negative 2. That doesn't work. So one extraneous solution. So I'll cross that one out. X equals 6 is the only solution to this equation. So that's a look at solving some equations that contain square roots.